Okay, so now in order to convert these numbers and solve this equation, basically there is a trick actually. It's just something like a trick, because otherwise you couldn't really get to these numbers. So the trick here is that, first of all, the simple cases, for example, let's say that you have, for example, instead of this number over here, which is, for example, let's say that you have 0.6666 and so on and so forth, and usually this number is written as 0.6 repeating, meaning that the 6 that the digit 6 basically repeats indefinitely. So, and then well, when you have this number over here, you usually want to, for whatever reason, you want to for example, round it up to, for example, 3 decimal places, 4 decimal places, and so on and so forth. So for example, if you want to round to, for example, 3 decimal places, what you will do is that you will write this as, basically 3 decimal places would be so many decimal places, and then just right to the 3rd decimal place you have the 6, which is greater than 5. So this you have to round up, meaning that all of these digits, you drop all of these digits and then add 1 to this digit over here. This becomes 0.667. So this is this number rounded to 3 decimal places. So now suppose that for example you have this number over here 0.65, and you want to write it in the form of a fraction, meaning that two numbers, basically the ratio of two numbers, for example, as a rational number. They call it the rational number. So what you do in this case is that you know that this is 65/100th, right? This is 65/100th. So you can write this number as 65 divided by 100, and then you can simplify this as much as you can. For example, divide by 5, you will get, for example, 65 divided by 5, you will get 1 times 5 is equal to 5, 15, 3 times 5 is equal to 15, so that's 13 by, for example, 100 divided by 5 is equal to 20. And 13 divided by 20 is equal to 0.65. 13 divided by 20 is equal to 0.65. So this, if you want to express this in terms of the irrational number, that would be 13/20th. 13/20ths. So this is easy. You have you usually have no problem with this. For example, if you had 0.333, there you would write this as, for example, you could write this as 333,000, and of course, well, you cannot divide by 2 or 3. So basically that's basically the rational form of this number, basically. So we have no problem with these, but when it comes to such numbers over here, suppose that I got this number over here from the calculator. Over here, I got this number 0.6667, and I know that the calculator has actually rounded up this number to 4 decimal places. Otherwise, this number has been originally 0.66666 repeating indefinitely. So since I want to get to the actual number, because this number basically when you have 0.6666 repeating, which is the same thing as 0.6 repeating, you can of course write this as approximately equal to 0.6667, or how many ever decimal places you want to have. There is no problem with that. But this is just an approximation. This is not the actual number. I mean, the number that you started with. So what I want here, because I cannot work with approximation here in this equation, I want the actual number. And of course, I cannot take this number as, basically, I could, for example, take this number as, for example, 0.67 or 0.667 or 0.6667 and so on and so forth. And then I could write this as 6700th. I could write this as 667,000. I could write this as 6667 10,000. And so on and so forth. But still that would not be the same number, because still I could go one more step and one more step and one more step, and this digit over here repeats itself indefinitely. So what it means is that I need to find some way to get rid of these digits and get to the number itself. And in order to do this, there is something like a trick that, but it does actually work, and it's a nice trick. Meaning that you can write your number, whatever that is, as, for example, x is equal to 0.666 repeating. And now I have this equation over here. I can multiply both sides of this equation by a factor of 10, for example. I would get 10x is equal to, and this decimal point moves to the right by one decimal place, because you're multiplying by 10. You'll get 6.6666 and so on and so forth. Now I have this equation number 2, and I had this equation number 1 over here. I can write this equation over here and subtract it from equation number 2, meaning that I can write x is equal to 0.666 and so on and so forth. This is equation number 1, and I can subtract, meaning that I can subtract this number from this number and this x from this 10x. This gives me 9x is equal, so 10x minus x is equal to 9x, and 6.6666 repeating minus 0.6666 repeating. You see that all of these, basically 0.666 repeating all the way up to infinity minus 0.666 repeating all the way up to infinity is going to be equal to 0. All of that will be cancelled out. And then here you have 6 minus 0, which is equal to 6. So then your x is equal to 6 divided by 9, which is divided by 3, you will get 2, divided by 3, you will get 3. So that means that your x is equal to 2/3. And now if you use a calculator and divide 2 by 3, you can see that you'll get the exact same number, 0.6666, and the calculator of course has to round the number to some decimal places, and this calculator shows all the way up to, I suppose, 1, 2, 3, around 12, 13 digits or so. I could, for example, show you another calculator that shows you more digits, but that has to round somewhere as well. So 2 divided by 3, for example, here you see more 6s over here, and this calculator gives you more digits, but eventually this has to round as well. So that's basically the whole story here. So this number is 2/3. This number is simply 2/3. So now the number over here is, so that means that one of the roots of my equation was 2/3, because the graph of the polynomial goes through the x-axis at x is equal to 2/3 over here, as you saw over here. X goes through the graph goes through the x-axis at this point, which is x is equal to 2/3. So now since m is equal to 2/3, since m is equal to 2/3 is a zero of this polynomial, what that means, and as you can see over here, this polynomial, although it's a 4th degree polynomial, it has only 2 real roots. It's supposed to have, basically you would expect that a 4th degree polynomial would give you 4 zeros, meaning that basically it would go through the x-axis at 4 different places, but it does go through the x-axis only at 2 different points, meaning that there are only 2 real roots and that you will get 2 imagined roots. We will see about that. So now, since I know that basically m is equal to 2/3 is actually a zero of this polynomial, so that means that m minus 2/3 is a factor of the polynomial, meaning that what it means to be a factor of the polynomial is that, for example, you have this factor over here, m minus 2/3, and this is a 1st degree factor because the degree of m is here 1, and I have one more factor over here like that, one more factor over here like that, and one more factor over here like that. All of them multiplied together gives me a 4th degree polynomial. So this is a 1st degree factor of this polynomial. And basically, when we factorize a polynomial, all that we do is basically we get these factors to get to the zeros, basically. So now, what that means is that now, since I know that this is a factor, if I divide this polynomial by this factor, I will get a 3rd degree polynomial, and of course I know the other 0 as well, but we will see about that. So I don't want to rush myself into anything. So now if I write 81 m raised to the power 4 plus 9m squared minus 18m minus 8, and if I divide that by m minus 2/3, what I will get is basically, so I have basically 81 m raised to the power 4, so I'll get over here 81 m raised to the power 3, and 81 m raised to the power 3 times m is equal to 81 m raised to the power 4, and 81 times negative 2/3 is equal to 81 m cubed times negative 2/3 is the same thing as 81 times 2 divided by 3 is equal to basically 81 divided by 3 is equal to 27, and this is 1. Now 27 times 2 is equal to 40, 54. Then you have a negative sign over here, so you have 81 m cubed times negative 2/3. So you have basically 27, and this cancels out. You get negative 54 m cubed. Negative 54 m cubed. So if you then basically if you subtract this from these two terms up here, you'll get a 0 up here. You will get a basically positive 54 m cubed, plus 9m squared, and then 54 m cubed divided by m is equal to basically 54 m squared. 54 m squared times m is equal to 54 m cubed. So 54 m cubed and 54 m squared times negative 2/3 is equal to Well, 54 divided by 3 is equal to, I suppose it was 27 times 2 is equal to 54, right? So this is 2 times 27, and 27 divided by 3 is equal to 9. And so you get 4 times n is equal to negative 36 there, m squared. So that's negative 36 m squared. So then basically negative positive, because I want to subtract, and these will be cancelled out. And then you have 9m squared plus 36m squared, which is equal to 45m squared. 45m squared, and then you have negative 18m. So then there you get plus 45m, so that would be 45m squared, and 45m times negative 2/3 is equal to, now 45 is the same thing as 9 times 45 divided by 3 is equal to 45 divided by 3, of course, is equal to 15. So this is 15, 1, that is 15 times 2 is equal to negative 30m, negative 30m. So over here I get negative 30m. So negative positive, and then I can basically cancel these two out. Negative 18 plus 30, 30 minus 18 is equal to positive 12m, and over here I have an 8, a negative 8, so plus 12, so that is 12m, and 12 times negative 2/3 is equal to 4 times negative 8, and then here you will get a 0. So then your polynomial basically becomes this polynomial times this polynomial. So your polynomial, whatever you had over here, becomes this 3rd degree polynomial times this polynomial. So this polynomial, I can write it as this polynomial times m minus 2/3 is equal to 0. Now again I can do the same thing, and over here I know that the other root, that the other 0 that I had was this point over here. Of course there are all kinds of techniques to basically get these numbers without looking at a graph or anything. You could calculate these numbers. There are well, a few ways, at least I know there are a few ways that you can get these numbers. But when your polynomial gets a little bit complicated, which is the case with this polynomial, and by complicated, what I mean is that when these numbers get too large, then it's a lot of trouble, because there is a whole lot of possibilities that you have to try, and it's just not, I mean, you have to learn it once, but it doesn't make any sense to try to do that, because it would take your whole lifetime to solve a simple polynomial. So now, anyway, the other root that I have over here is negative 0.333 repeating. So this number is also a 0 of this polynomial. So negative, it is, of course, it's a negative number, but we don't have to worry about that right now. But the number itself is 0.333 repeating, and so on and so forth. So to find some rational number like this for this number, I can write it as x is equal to 0.333 and so on and so forth. And if if I multiply this by a 10, I'll get 10x is equal to basically 3.333 repeating. And now if I write this down here, x is equal to basically 0.333 and so on and so forth. If I subtract here, I'll get 9x, and get over here, I'll get a it doesn't make any sense. X is equal to 3.33 and so on and so forth, and x is equal to 0.33, so 10x minus x is equal to 9x, and if I subtract, these will be 0 and you get the 3 over here. I see. Okay, so x is equal to 3/9, which is equal to 1/3. Now 1/3, if you use a calculator, basically 1 divided by 3 is equal to, as you can see, 0.333 and so on and so forth. So, so the number is 1/3, and it is negative 1/3. Negative 1/3. So what that means is that another factor of this polynomial is negative 1/3. That means that, I'm sorry, another 0 of this polynomial is negative 1/3, and so the factor related to that is x is m minus negative 1/3, which is equal to m plus 1/3. Okay. So now what that means is that you can divide this third degree polynomial, which is equal to 81 m cubed plus 54 m squared plus 45 m plus 12, and if you want to divide that m plus 1/3, that is equal to basically 81 m squared. So that's 81 m squared, 81 m cubed, I'm sorry, 81 m cubed, and 81 divided by 3 is equal to 27. That's 27 m squared. Subtract, so you get 54 minus 27, which is equal to 54 minus 27, which is equal to basically this is a 4, this is 14, 7, and 27. So that's 27 m squared plus 45 m. Now you have plus 27 m, so 27 m times m is equal to 27 m squared, and 27 divided by 3 is equal to 9m plus 9m. And subtract, you will get a 0 over here, and 45 minus 9 is equal to 36m plus 12, and you get 36 over here. 36 times m is equal to 36m. 36 divided by 3 is equal to 12, and you'll get a 0 over here. So then you can write your polynomial, this part, you can write it as this polynomial times this polynomial times x plus 1/3. And you have this polynomial as well, m minus 2/3 is equal to 0. So now basically you have only a second degree polynomial, and that you can factorize as well, hopefully, meaning that you have 81 m squared plus 27m plus 36 is equal to 0, for example. and 81 is basically divisible by 3. This is divisible by 3, this is divisible by 3. And 81, you know, it's equal to 9 times 9. So 81 is equal to 3 raised to the power 4. 3 raised to the power 4. 27 is 3 raised to the power 3. 3 raised to the power 3, and 36 is 3 times 12. It's 3 times 12, which is, so you can only divide by 3 apparently. So divide by 3, you will get 27m squared plus 9m plus 12. And then over here, the roots of this polynomial are this is also a tough one, because you do need to somehow figure out some number whose product is 12 times 27, and basically you need to calculate this, and also you have a 9 over here. Now you need to find two numbers a and b such that the product of these numbers is this number, and the sum of these two numbers is this number, and then those two numbers you can use to factorize this equation. But I suppose this equation is does not even have real roots, so I'm not going to try that. And moreover, if you calculate the determinant of this equation, what you will get out of this polynomial, you will get b squared minus 4ac. You will get basically 81 minus 4 times 27 times 12, and you can see that you're getting a negative number over here. You're getting a negative number over here, so that means that you will have basically two real roots related to this polynomial. So of course we are not, I mean, the two imaginary roots, we cannot do anything with them, and you can see the same thing from here as well. And as you can see, basically the only two roots that we calculated are the real roots, and the two roots that are not real, of course, are not shown here. So you can simply now forget about this part of the equation, because it's going to give you two imaginary roots. And so now the question that we had was basically now basically we were looking for some, I think for some slopes over here, and here we got to basically, we said that basically this distance is supposed to be equal to 3, and then we got two values for m over here, and the two values for m are, so now this part is not important. Over here you have, and this is supposed to be m, so that means that basically when this whole thing is equal to 0, either m plus 1/3 is equal to 0, or basically m minus 2/3 is equal to 0, or basically this thing is equal to 0, which gives you two imaginary roots. Over here, that means that m is equal to basically negative 1/3. M is equal to negative 1/3, and over here that means that m is equal to 2/3. So negative 1/3. Now what that means is that number 16 I don't really remember what I was doing over here, and so I cannot make sense of what I did really. So what I did was that I got the equation of that line in terms of m, and now what that means is that the slope of this line is going to be -1/3 and 2/3. But the problem is that the right answer in the book is a little bit different, meaning that the line is supposed to be parallel to the x-axis or parallel to the y-axis. Okay, we will see about that. I take a few minutes rest, and I'll go back and see what I did wrong, and then I'll come back and report to you what's supposed to be done here now. Okay, so basically it seems that all of the points that basically the point that we found over here, this was correct. There was no problem with that, and basically and well, it seems that we have made some mistakes while solving this equation over here, the equation that we wrote over here based on the distance formula. And there were some good things in there, so I did not erase those things, because they come in handy for many different kinds of situations. So I'm going to basically erase this part. I'm going to erase this part and calculate this part again. Otherwise, all of the explanation related to those decimal numbers and the conversions and everything else is useful for different situations, so you can keep them. But otherwise, the equation was not. And here we talked about these polynomials and factorization and everything. These are all useful stuff. So again, basically what you have over here is basically x2 minus x1, x2 minus x1 whole square plus y2 minus y1 whole square, the square root of that, and that is equal to 3. So I write this as 3 is equal to the square root of basically x2 minus x1, which is 2 minus m over 1 plus m, minus x1, which is equal to -1, so that becomes plus 1 all squared plus basically 5m plus 2 over 1 plus m minus 2 whole squared and so that you can write as you can raise both basically this both sides of this equation into the second power. You can write it as 9 is equal to 2 minus m over 1 plus m plus 1 whole squared plus 5m plus 2 over 1 plus m minus 2 whole squared. And this is equal to, basically 9 is equal to, basically you can write this as 1 plus m, 2 minus m plus 1 plus m whole squared plus 1 plus m, 1 plus m. You have here 5m plus 2, and over here you have negative 2m whole squared, and over here you have basically m and m cancels out. 2 plus 1 is equal to 3, 3 squared is equal to 9 over, so this is 9 over 1 plus m whole squared, and this is equal to 9. And this is over here you have basically, so over here you have 5m minus 2m is equal to 3m, so that's 3m, and then 2 minus 2 cancels out, 1 plus m whole squared, which is 9m squared, and then you can write this as, I don't know why we did all of those weird things. I mean, it was actually a very simple equation. So then 9 is equal to 1 plus m whole squared, 9 plus 9m squared, and then you can take over here, take a 9 out. Over here you can take a 9 out and write it as 1 plus m squared, and so you can basically forget about this part, and these two can cancel out, you get 1. And so 1 plus m squared is equal to a squared plus b squared, right? So that is a squared plus b squared. So you know that a plus b whole squared is equal to a squared plus b squared plus 2ab. So that means that a squared plus b squared is equal to a plus b whole squared minus 2ab. So which is not going to help me much. Okay, we can expand them. That's not a problem. We can expand these. So basically now this becomes, if I cross multiply, I will get 1 plus m squared is equal to 1 plus m whole squared, which means that 1 plus m squared is equal to 1 plus m squared plus 2m, and m squared and m squared you can cancel out, 1 and 1 you can cancel out. That means that 2m is equal to 0. 2m is equal to 0, that means that m is equal to 0. That means that the slope of the line has to be 0, meaning that the line goes through this point and the slope is 0. That means that it's parallel to the x-axis. It would be some line like this. It would be basically some line like this. So that's basic, but of course there is something else in the book that there is some other answer in the book which gives you m is equal to which gives you which must give you something like m is undefined, and that means that basically the line is parallel to the y-axis as well. So this could also be, I mean these two must be the same distances. But then I suppose if you were to do that, then when you raise this to the second power, then you basically need to write this as let me see, for example, let's say you have, for example, the square root of 9 is equal to 3, right? So then if you raise both sides of this equation to the second, or let's say that, for example, the square root of there's the square root of a, or the square root of, for example, 9, the square root of 9 is equal to x, for example. Then what that means is that your x can be, what that means is that x is equal to plus or minus 3, meaning that positive 3 whole squared is equal to 9 and negative 3 whole squared is equal to 9. So when you have this kind of situation, which is, for example, the square root of some expression is equal to some other expression, when you raise both sides of this equation to the second power, what you need to do is that, for example, when you have the square root of a is equal to b, what that means is that basically the square root of a whole squared is equal to plus or minus, is equal to, basically, if I raise both sides of this equation to the second power, then what I will get is basically the square root of a whole squared is plus or minus a, and that is equal to b squared. So that means that a is equal to plus or minus b squared, something like that. So if we had done this, we didn't take care of the negative side of this, and so we got only one answer. If we had done that, we would have gotten basically plus or minus 9, and then probably somewhere we would have gotten m as undefined, which means that the line is parallel to the y-axis, and that is basically the whole story. But one answer is also fine as long as you understand this part over here. Okay, so that is basically that. Now we have a couple more questions here. There's question number 18. I'm sorry, 17. There is also 17, 16. So where is 18, 19? Okay. There is question number 17, which is not here. So what is question number 17? So we will, the next thing that we have is question number 17. Okay, so the next question is also an interesting question. These are all very practical things. So let me create a new layer here, because I suppose we are going to need some space over here. So the question is, the hypotenuse of a right angle triangle as its ends at the points 1, 3, and -4, negative 4 comma 1, negative 4 comma 1. Find an equation of the legs or the perpendicular sides of the triangle. So suppose that you have this, basically 1 comma 3 is 1, 1, 1, 2, and 3 over here. This is 1 comma 3, and negative 4 comma 1 is 1, 2, 3, 4, and comma 1 over here. So this is the hypotenuse of the triangle. Now you could, basically this is 1 comma 3, and this is basically negative 4 comma 1, negative 4 comma 1. And you could basically find the perpendicular sides in such a way that you have for example, some well, of course it's very easy. That doesn't need any sort of calculation, because you see that you will need a side over here and a side perpendicular to that over here. So this is a vertical line, and over here your x is equal to 1. So this would be basically x is equal to 1, and over here your y is equal to basically 1. So y is equal to 1. That would be, for example, one possible answer. So there is nothing really to do here. There is really nothing to do here. That is the answer. X is equal to 1, y is equal to 1. So the next question is question number 18. Is find the image of the point 3, 8 with respect to the line x plus 3y is equal to 7, assuming the line to be a plane mirror. So you want to find the image of the point 3, 8 in the line x plus 3y is equal to 7, assuming the line to be a plane mirror. So what this means, a line being a plane mirror with respect to a point and the image of the point in that line, is that suppose that you have this point over here, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So basically 3, 8 is this point over here. And this line over here is 3y is equal to negative x plus 7. 3y is equal to negative x plus 7, or y is equal to negative 1/3 x plus 7/3 and 6 is 2 and 1/3. 7/3 is the same thing as basically 7 divided by 3 is equal to 2 times 3 is equal to 6. So this is 2 and 1/3. So 2 and 1/3 is your y-intercept, which is basically some point over here, and negative 1/3 is your slope, which means that for 3 horizontal units of change, you will have negative 1 units of vertical change. So 1, 2, 3, and basically you would end up somewhere over here. Of course, these are all not very accurate, but this would be your line. And of course, this is your x and y axis. So now this line over here is x plus 3, x plus 3, y is equal to 7. This line. Now what you want to, now if I assume that the line to be a plane mirror means that basically that you could imagine that the line, basically that the point goes through this plane mirror and is kind of the image of this point is basically produced on the other side of the line. And of course the angle is 90 degrees and the same distance over here, and you would get, for example, some point right over here. Okay, so some point over here. Of course this is supposed to be a straight line. Okay, so this angle is 90 degrees, and this point is the image of 3, 8 in the line x plus 3y is equal to 7. You want to find this point over here. Okay, now the way that you can do that is that, of course, you know that these two lines are perpendicular. Since the two lines are perpendicular, and you know the equation of this line, you do know the equation of this line, and so what you can do is that based on the equation of this line, you can find the slope and the equation of this line. Meaning that if I call this, for example, line 1, so 1 basically gives me 3y is equal to negative x plus 3y is equal to negative x plus 7, so y is equal to negative 1/3 x plus 7/3. And so over here m1 is equal to negative 1/3. Now since the two lines, I call it not line number 2, for example, since 1 and 2 are perpendicular, if I call the slope of this m2, then you know that m1 times m2 is equal to negative 1. m1 times m2 is equal to negative 1. So that means that negative 1/3 times m2 is equal to negative 1, and m2 is equal to, you can cancel these two out, 1 divided by 1/3, which is equal to 3. So m2 is equal to 3. Now, since m2 is equal to 3 and one point on this line is 3, 8, if you have 3, 8 on the line and m2 is equal to 3, so then you can write basically, then you can write y minus y1 is equal to m times x minus x1, which means that y minus 8 is equal to 3 times x minus 3, and y minus 8 is equal to 3x minus 9, so y is equal to 3x, and negative 9 plus 8 is equal to negative 1. That is the equation of the other line. Y is equal to 3x minus 1. Over here, y is equal to 3x minus 1. And as you can see, it goes through the y-axis somewhere very, very close to negative 1. And of course, it is not, I mean, based on the scales that we have, it's not quite negative 1, and that's due to, well, basically, of course, the line that I have drawn over here is not completely perpendicular, so you can expect these kinds of minor errors in these kinds of constructions that I do here. So now I have basically I have the equation of this line, the equation of this line. So I can write it as, I can write y is equal to negative 1/3 x plus 7/3, and y is equal to 3x minus 1, and use it as a system of equations to find the point of intersection of the two lines. Meaning that I can subtract this equation from this equation, negative, 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 positive, and so you have 0 over here, and so negative 1/3 negative 3 is negative 1/3 negative 3 is equal to negative 1/3 minus 9/3 is equal to negative 10/3, negative 10/3 x, and 7/3 plus 1, 7/3 plus 1 is equal to, this is 2 and 1/3, so 3 and 1/3, I suppose, 3 and 1/3. So 7/3 plus 1, 7/3 plus 1 is equal to 7/3 plus 3/3, which is equal to 10/3, which is equal to 3 times 3 is equal to 9, or basically 9 and 1, so 3 and 1/3. 3 and 1/3, which is 10/3. So that is plus 10/3. So this is equal to 0, because the y's were cancelled out here. So what I can do is now negative 10/3, negative 10/3 x is equal to negative 10/3. These you can cancel out, these you can cancel out, these you can cancel out, x is equal to 1. X is equal to 1, which makes sense, because at this point x is equal to 1. Now if x is equal to 1, over here we have y is equal to negative 1/3 x plus 7/3. So y is equal to negative 1/3 times 1 plus 7/3, which is equal to 7 minus 1 is equal to 6, so that's 6/3, which is equal to 2. Y is equal to 2. And again, it makes sense because the height of this point is 2. So that is 1 comma 2. So now that we have all of these things figured out, so now you need to find the, you can find the perpendicular distance of these 2 points, of course, using simply using the distance formula, for example. And of course you know that it is the perpendicular distance, not just normal ordinary distance. And then we have a formula which basically calculates the perpendicular distance of some point from some line for you, meaning that we said that if you have x1, y1, and some line, for example, ax plus by plus c, is equal to 0. If you have this line and this point, then the perpendicular distance of this point from this line is given by d is equal to the absolute value of ax1 plus by1 plus c over the square root of a squared plus b squared. Now we know this. Now if I use the distance formula, I can find the perpendicular distance of these 2 points, and that should be the same thing as the distance between this point and this point. Now suppose that I use the distance formula, and then I could get the distance between these 2 points, and then I can put it over here, put that over here, and then we will be able to actually get the get the coordinates of this point over here, because we have the equation of the line as well. But let's first go for the distance formula, and then we will do things step by step. So what I want to do now is that I want to find the distance between these 2 points, 3, 8 and 1, 2. 3, 8 and 1, 2. So you know that AB is equal to the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared, and so AB is equal to the square root of x2 minus x1, so 1 minus 3 whole squared plus 2 minus 8 whole squared, which is equal to the square root of, that is negative 2 whole squared is equal to 4, that is negative 6 whole squared is equal to 36, that is the square root of 40, which is equal to 4 times 10, that is 4 times 10, then 10 is 2 times 5, so that's 2 square root of 10. That's 2 square root of 10. And so the distance between these 2 points, if I call this point A, and if I call this point M, and if I call this point B, for example, AM is equal to 2 square root of 10. AM is equal to 2 square root of 10. Now, what we need to do now is basically use this formula, which is basically the D is equal to the absolute value of AX1 plus BY1, and I know that this is a perpendicular distance, not just ordinary distance. This is the perpendicular distance, okay? This is the perpendicular distance. So I use this formula, and this formula calculates perpendicular distance for you, not ordinary distance, plus C over square root of A squared plus B squared. And so I know that, and I want to find the coordinates of this point over here, which is basically over here is given by x1, y1, and also there is a line in here which is ax plus by plus c is equal to 0, right? So the line is basically this line over here. The equation of the line I already have. It is x plus 3y minus 7 is equal to 0. And the point is, I don't know what the point is. It's x1, y1. I want to find out what the point is. And the distance is supposed to be 2 square root of 10 units. And D is 2 square root of 10 units. So then I put all of these in the formula. 2 square root of 10 is equal to this, the absolute value of A over here is 1. X1 is x1. B is 3 times y1, which is equal to y1. And C is negative 7 over here, over the square root of A squared, which is 1. 1 squared is 1. 3 squared is equal to 9. So that's square root of 10. So what that means is that 2 times square root of 10 is equal to the absolute value of x1 plus 3y1 minus 7 over the square root of 10. And if you cross multiply, you will get 2 times square root of 10 times square root of 10 is equal to 10, which is, and 10 times 2 is equal to 20, is equal to the absolute value of x1 plus 3y1 minus 7. And then you can solve this equation, meaning that you can write basically x1 plus 3 times y1 minus 7 is equal to plus or minus 20. And so what that means is that then basically x1 plus 3 times y1 minus 7 is equal to 20, or x1 plus 3 times y1 minus 7 is equal to negative 20. And then you have these two cases over here. And that gives you some relationship between x1 and y1. And then we can use it over here to find the coordinates of this point using the equation of this line, which we already have So over here, this is basically x1 plus 3 times y1. Now this 20 comes to the other side, becomes negative 27. Negative 27 is equal to 0. Or you can say that x1 plus 3 times y1. Now this is 20 minus 7, which is equal to 13, is equal to 0. Now you can just hang on to these formulas. Now you know that this point, whose coordinates are x1, y1, is basically on this line over here. Y is equal to 3x minus 1. Y is equal to 3x minus 1. That means that this point has to basically it has to the relationship between for example, let's say let me show you what I mean. So if I use, for example, this equation over here, I can write x1 is equal to, for example, negative 3 y1 plus 27. x1 is equal to negative 3 y1 plus 27. And of course, instead of x1 y1, I can simply write x and y, because this point is just simply lies on this line. So I can just simply use x and y. So I can write x is equal to negative 3y plus 27. So then I can put this x in this equation, write it as y is equal to negative 3, y is equal to 3 times x, which is equal to negative 3y plus 27, 3x minus 1. And that gives me y is equal to negative 9y plus 81 minus 1. So y is equal to negative 9y, and over here 81 minus 1 is equal to 80 plus 80. I'll take this to the other side. Y plus 9y is equal to 80. So that means that your y is equal to, means that 10y is equal to 80, and y is equal to 80 divided by 10, which is equal to 8. Your y is equal to 8. And if I use this equation over here, for example, again, I can get x1 plus 3, or I can write it as simply x and y. So x plus 3y minus 27 is equal to 0. Now if y is equal to 8, x plus 3 times 8 minus 27 is equal to 0. X plus 24 minus 27 is equal to 0. X minus 3 is equal to 0. X is equal to 3. So 3 comma 8 is this point over here. I already had it, but it gives me 2 points, because there is one point over here which satisfies these two equations. I mean, one of these equations is related to this point. One of them is related to this one, but there is unfortunately no way to know which one. You have to try them. So now I'm going to try this one, and this is this is definitely the one that we are interested in. So now again, the equation of the line is basically y is equal to 3x minus 1. 3x minus 1. And this equation is x1 plus 3 times y1 plus 13 is equal to 0. So now I can use this equation as, for example, write x1 is equal to negative 3 times y1 minus 13. And I can rewrite this as x is equal to negative 3y minus 13. And then put this x in this equation. So y is equal to 3 times negative 3y minus 13 minus 1. And of course this gives me y is equal to negative 9y negative 39 minus 1. So this goes to the other side. 9y plus y is equal to 10y is equal to negative 40. Y is equal to negative 40 over 10, which is equal to negative 4. Y is equal to negative 4. Negative 4. Now I can use the same equation. For example, I can use either this one or this one. So I can write x1 plus 3 times y1 plus 13 is equal to 0. So now x1 plus 3 times negative 4 plus 13 is equal to 0. And x1 minus 12 plus 13 is equal to 0. So x1 plus 1 is equal to 0. x1 is equal to negative 1. So the point is negative 1 comma negative 4. Negative 1 comma negative 4, which is negative 1, this point over here. Negative 1 comma negative 4, this point over here. This is negative 1 comma negative 4. So after so much calculation, you get to the point that you were looking for, which is negative 1 comma negative 4. Okay. So I hope that you enjoyed this video, and we have still a couple of videos to go to, a couple of exercises to go to get to the end of this, to the end of these exercises. We have 19, 20, 21, 22, 23, 24. But they are all fun and necessary, so we will go through them one by one, and I'll see you in the next video.